Welcome back to Electro Gadget. Today we will learn how to build a smart IoT battery management system using ESP32 and Arduino IoT platform. It will constantly track real-time battery voltage and status with advanced overcharging and overheating protection. So let's jump into the project. ESP32 development board, which will handle all of the operations of our project. We chose it because of more analog pins available. TP4056, lithium-ion battery charging module for charging 3.7-volt battery. A 5-volt solid-state relay module to integrate auto-cut system. It will automatically cut the power when the battery will be full or the temperature will arise. A multi-level shifter which will step down the voltage to 3.3 volts from 5 volts to 24 volts. It will help to power the ESP32 as it operates using 3.3 volt supply. A temperature sensor which will simultaneously detect battery temperature, and if a certain level reach it, will signal ESP32 to cut the power supply from the battery to prevent overheating. 2. 10 kilo ohm resistors for voltage divider and one 10 kilo ohm resistor for temperature sensor. A 3.7 volt lithium-ion battery for testing purpose. A 1-module 3.7 volt lithium-ion battery holder. First place ESP32 on the breadboard. Next place multi-level shifter voltage converter on the breadboard. Connect positive VCC rail of both sides using jumper wire. Connect negative ground rail of both sides using jumper wire. Connect level shifter VCC with 5-volt supply. Connect level shifter ground with negative rail of the breadboard. Connect ESP32V input pin with level shifter 3.3 volt pin using jumper wire. Connect ESP32 ground pin with negative rail of the breadboard using jumper wire. Now solder TP4056 charging module battery plus and battery minus terminal for further connection with ESP32. Now solder TP4056 charging module's output plus and output minus terminals using jumper wire. It will connect to the ESP32 using voltage divider circuit. Solder TP4056 charging module's input plus and input minus terminals using jumper wires. Here we will connect the 5-volt power supply to charge the module. Place two 10 kilo ohm resistors in series to build a voltage divider circuit. Connect D34 pin from the ESP32 to the middle of the series resistor of the voltage divider. Connect output plus and minus pin to the both sides of the series resistor's terminal. Connect a 10 kilo ohm resistor between the temperature sensor and 3.3 volt source. Place one end of the temperature sensor with the another leg of 10 kilo ohm resistor and another end with ground. Connect D35 pin with the temperature sensor. Connect input plus pin of the TP4056 with relay module and input minus pin with negative rail of the breadboard. Connect another terminal of the relay module with direct plus 5-volt DC supply. Connect VCC of the relay module with direct plus 5-volt supply. Connect ground of the relay module with direct ground supply. Connect data pin of the relay module with D4 pin of the ESP32. Come to the Arduino IoT Dashboard setup. Click here to continue the setup page. Click on the Device tab. Click on the Add Device. Select third-party device and choose ESP32 and model ESP32 Dev module. Rename the device with BMS ESP. Now continue and download these two authentications in your PC for future update. Remember to keep the secret key safe, as it cannot be recovered further. After the device setup, click on the Things tab and select Create Thing. Rename the thing name as Smart BMS System. Now click on Add Variable and do the same process here as it is. Now click on this link icon and link BMS ESP32 as the thing device. After linking, configure your Wi-Fi router name, password, and the secret key you have just downloaded. Copy the code, which I already provided, into my website, link into description, and paste it in that sketch tab and hit download button and save it into your PC. Extract the zip file and open the .ino file into your Arduino IDE. Now click on the secret.h tab and change the value of Wi-Fi name, password, and secret key with your own configuration. Now select ESP32 dev module as board, COM port 3 as USB port, and hit Upload button. It is time to test our project. Place a 3.7-volt battery for testing purpose. Thanks for watching. Please like, share, and subscribe. Your support is necessary to grow this small channel.